Assalamualaikum and very good morning to those who are joining the talk today. I would like to thank to MACE, Malaysian Society for Automatic Control, for the invitations for MACE Monday Tech Talk. I'm Ibrahim, the speaker for today. Today I would like to share the topics on advancement in AI, revolutionize industry and accelerates research. The topic will be focused on computer vision based, utilizing AI, or recently we are so much working on a deep learning algorithm for computer visions. Okay, so for today's talk, this is the outline. So there are few topics or section to be discussed related to AI for computer visions. Okay, as for introductions, in Cairo, in UTM, I think we are working to promote AI from the academic point of view, from the SMEs, and also some of the big companies that we are working with on the AI to provide some consultation work and also solutions, software developments, and also kind of discussions or awareness to the society. So this is some of the research visibility for us to educate people, the community on related issues on AI, right? So also, I think being the academia in UTM, specifically in Cairo, so I'm also part of the NVIDIA ecosystem, sharing a lot of training throughout the Asian region. And this is an example that we share the AI to our industrial developer in Thailand last time, I think in 2018. And also we have the opportunity to share, to highlight or to provide some of the awareness on the business development on AI in edX Bangsa. Right. So again, I'm from Cairo. So Cairo is Center of Artificial Intelligence and Robotics. Okay, it was founded in 1997 and recently ranked among top 5 high COE in UTM based on key performance indicator in 2015 last time. So established Cairo NVIDIA Joint Lab in 2018. So basically we have 2 offices, one in Kuala Lumpur, in UTM Kuala Lumpur, and the other one in Johor Bahru, in our main campus in Johor Bahru, in Skudai. So just a quick one. So this is what Cairo have done for the last 20 years, focusing on AI, control and automations, robotics and mechatronics. And also, this is where we are contribute to the community, to the research academic world. So we are securing more than 15 million grants as since of the beginning with 4 spin-off company. We also organize a big conference, right? More than 300 index journal publication from our center. And then we have some of them is already an alumni, more than 200 postgraduate students, current and the alumni. All right, so just to share, I think when we start focus myself on AI, I think this is what we start in 2018. We managed to secure NVIDIA DJX station. This is where we start to have AI or tools for us to develop AI engine specifically on computer visions. So this is the tools that we utilize that helps us a lot to make the modeling faster. So in our lab, earlier we completely relies on this particular card, or even just to share earlier when we start, we are simply utilizing the gaming card, known as GTX 10X0 when we start in 2017. All right, so this is what we are develop or grow our lab so that we have a good ecosystem to be the enabler for AI deep learning. So we are open for any collaborations to our friends, to our collaborator outside in utilizing the facilities that we have. Okay, so this is the environment or the facilities that we have in our lab, specifically in Cairo UTM in KL campus. All right, so this is some overview of AI deep learning that I would like to share with all participants today. So this is the Moore's law theorem. So just to share, this is basically what GPU can offer, all right, in terms of the computing. So basically, we are looking at either at the application level. So as the academia on the AI deep learning, so much we are working on the algorithms to improve our solutions, especially on AI algorithms. And so basically we have the system level and the CUDA architecture. This is where GPU plays very important role to provide a platform, especially on AI for the training purpose or building up the model. So this is just an example on throughout the world running from the old CPU. They are converting their lab into a GPU, okay, graphical processing unit. For instance, NVIDIA GPU accelerates 127 of top 500 system up from 86 years ago. 48% increase. NVIDIA GPU also power 22 of top 25 greenest system in the world. Right. So this is basically the needs of the supercomputer, which fueled by the GPU. Right. On top of that, I think when we talk about AI, so we are so much relies on several available library so that we can utilize the GPU power. So for instance, if you talk about apps and framework, I think every one of us, those who already started with AI, you are familiar with some of the items here, including like a Python programming, right? And then we have the AI framework, like a TensorFlow by Google's, MXNet, Onyx, PyTorch, right? Rapids, Kaldi, Chainer. So this is some of the example on the AI frameworks, right? So on top of that, they also have the HPC software on this one. So today interest is mostly on the AI framework. So instead of looking at the framework, so this is what normally you can have a look on the machine learning perspective on the NVIDIA SDK libraries. So because when we start on developments of AI, we cannot run away from all these libraries. For instance, if you talk about deep learning, by default, we have the CUDNN, right? CUBLAST, yes, CUBLAST, and Nickel, we call Nickel TensorRT, for instance, so for the optimizations. Right, so on top of this, they have a CUDA, and this is all the Tesla GPU system that powered the AI development. Before we look at a very specific customer use case, either in consumer internet, industrial application, and also for HPC on the supercomputing. Just quick one. So this is what we can utilize from the stack. So for today, we just mostly focus on deep learning. And definitely some of it we can look on the machine learning parts. Right. So what is AI? So those who are new to this field, AI is just like a big white canvas. if you see on the screen. So there are various type of AI. Okay, so what makes AI getting popular? This is my understanding, and this is what makes AI coming back. So prior to that, we have the machine learning, right? And then people are focusing so much on the neural networks, and then after they have some breakthrough in the algorithms with quite a big network or big configurations, so people are focusing on deep learning. So in terms of the time frame, so this is what we have. If you define intelligence as the ability to achieve complex goals, then learning is the ability to achieve more complex goals today than we could yesterday. So this is the idea from AI to machine learning in 80s until I think we have a breakthrough on the AI, on specifically on deep learning in 2010. So that's why they give a lot of attentions on AI. All right. For instance, in this course, basically, we want to share with you on the idea of deep learning, where people using the algorithm inspired by human brain and strategies inspired by human learning to achieve our most complex goals by harnessing the power of parallel computing for GPU. All right, so this is the idea of deep neural networks. All right, so deep learning generalized solution across problem. So this is the best part. So if you look on the input of the network, if you those new to this image, on the most left, it is basically we consider as the input to our network. And then we have our network in the middle with a neuron here. If you look here, we have a neuron here. The connections of the neurons makes the network, right? So, and then this is the output. So if you look on structured and unstructured, so we have a structured input like a numbers, unstructured input like image, sound, video, and text. For today, I'm just so much focusing on images as the input to the network. Right, so what basically deep learning do? Right, so if you look here, so this is basically raw data, which is our input. All right, so if you look, our input here is a shape of car. So let's say if you want to classify or to determine this is a car. So what basically AI deep learning, specifically on this computer vision applications, is trying to get a good features, the information that can be translated as the output. It is a car. So what really happens in the middle of the network, where the network is keep updated. So all the connection from the layer to another layer is basically a week. So this week being updated with the process of learning, right? That's a very simple idea. So what the learning process trying to do is basically we're trying to find a good features that resembles, this is the features of the car. All right, so at the beginning of the network, the earlier part of the connections, we have the low level features, mid-level features, and towards the end of the network configurations, we have the high level features that can be used to translate, this is a car, for instance. All right, so this is what basically deep learning trying to do. Okay, previously, I have a good slide after this. I'll share with you how the previous machine learning trying to solve the similar problem. If you look on the computer visions, there are variety of problem, including classifications, localizations, and also object detections. Of course, we have segmentations and many more. Okay, we scope our talk of discussion today, and some of the application are so much focusing on these three types of algorithms. First, we have the classification. You pass the whole images, and then what is the most dominant input or the dominant object in the image. So we don't care about where the object is. So this is classification. Let's say we have one object, then we want to know exactly the locations So this is called localizations. So when we expand the idea of localization with several objects to be determined in one image, this is what we call the object detections. So this is where people put a lot of interest. So as academia, we are looking at various the improvements of the algorithms. Either it can be a pre-processing, the improvement of the algorithm itself, or some sort of post-processing to improve the quality of the detections. So prior to the deep learning, so if you look on the conventional machine learning, I think 80s until now, people are looking and trying to use it. So if you look on the image here, so on the top, we have the classic machine learning. So what makes difference is the hand design features. So these features is mostly relies, especially on the computer vision applications or image processing application. They are relies on the advancements of image processing algorithm or techniques, so that they can have a good features to be used for the machine learning, right? So, but if you look on the breakthrough in 2010, in 2012 until now, so all this become end-to-end, where the features is being resembled by the network itself on the deep learning architecture. All right, so this is an example. Okay, without DNN, we have to write a programs, for instance. Okay, where we have to write program to determine or to understand the handwritten with the number 2 here. So with the machine learning, what we need to do, we need to have like edge filter, for instance, a different type of filters, so that we can extract important features to tell this is a number 2, for instance. So in deep learning, what we're passing is basically a spatial information or a pixel representations of number 2 here to the network, so that the network can understand the pixel configurations to tell this is number 2, for instance. Right. So a layer by layer, from the low level features to the medium level features to the highest level features. So when we're passing a new handwritten, so we expect the deep neural network can classify correctly, this is number 2. And it's proof using this data set, I think AlexNet, for instance, in 2010, 2012, where they found the solutions to do this MNIST data set. Okay, so this is where they get the breakthrough with the network with highest level of accuracy at the time, up to 99.6% of accuracy. All right, so that trick that give a lot of attentions by the community, not only from the academic world, but also from the point of view, on the industrial point of view. So this is some potential applications where retailers have been capture a lot of opportunity using the AI as enterprise solution. So we can look what else we can contribute. And I believe this report been produced, I think, sometime in 2019. So you can see almost all these areas already been covered, or at least they have some AI solutions for these industrial applications or sector, for instance. But in reality, it's not easy. So this is some of the industry challenges, like the high throughput. So we're looking for bandwidth and network throughput is growing exponentially with the 5G nowadays. Privacy and security. So we talk about security issues like a DDoS attack, ransomware are increasing every day. So this is what AI can help on having the solution for our cybersecurity. So we talk about complex problem, low latency services, real-time applications, a big data on the exponential data. Okay, for instance, the connected endpoint will no more be a smartphone anymore. To this, it will be robots, cars that will generate petabytes of data and in a day, and network will need to deal with this volume. So this is the real challenge that AI to anticipates in solving the real human problems. So what AI is fueling global industry as of now, there are more than this, but there are some popular applications like AI cities, public safety, healthcare. We have startups that working on various AI, industrial applications, and also the transportation. All right, so that's why if you really interested, either look on the cloud-based GPU for your modeling, or your own system with GPU accelerated, you may think twice. I think so. This is some of our experience in lab. When earlier we start our modeling, we run on the gaming GPU card, and at one time it is not able to cater our needs on the modeling, and then we migrate to some of the application on the Amazon, for instance. So when we have heavily, not only from the student that develop the algorithm for their PhD or their master study, and also some of the problem that we trying to solve involve the real industrial application. So we have the opportunity, we managed to secure some grants. We bring the, I mentioned earlier, we have the DGX station, and recently we managed to secure one big grants. We have our new E100 GPU card that helps us a lot on the modeling. So this is like a key words when we are seriously developing the AI algorithm, so that there will be less time for us to do the modeling as compared if you relies on the CPU-based solutions here. So this is just an example, traditional HPC cluster. So this is some of the V100, and even now we are moving to, this is what we have earlier in Cairo 2018 with the V100. So just to share what we want to see from the point of view end-to-end product. So we have from the fully integrated DL supercomputer, we talk about DGX E100, for instance, nowadays. So we have several cards on this one. On the data center, we talk about a specific Tesla architecture card, Ampere architecture card, and recent one, they have a new family for the GPU card. For the automotive, with the embedded with a high power processing, we have a few GPU card that can be used for the automotive applications, and the embedded one. So for instance, if you talk about Jetson Xavier, you can start with some of development tools, kits like a Jetson Nano, for instance, either with a 2 GB or 4 GB RAM, for instance. So this is the idea of having the end-to-end solution. So you can imagine you train everything in your supercomputer, and then you can serialize your model into your embedded solution, for instance. All right, this is again some of the GPU computing platform. Okay, instead of looking at the framework just now, so they have a few applications including HPC frameworks, enterprise, data analytic visualizations. Okay, so they also have immediate solution. Okay, if you look at these industry solution, but again, for my understanding, having AI, developing some of the AI algorithm, AI always requires some of the customizations. So that's why we need to have a good engine and good understanding on the AI, either from the perspective of data analytics, from the perspective of data engineering, and even at the lowest end, we need to talk about people in that appreciate their data set so much. For instance, on those who are working on the data curations, for instance. So this is the most valuable people in the organizations. If we talk about developing AI, where people need to really appreciate or understanding their data set in the perspective of the experts, and also in the perspective of AI development. So once we have all these things, So this GPU computing platform will be very valuable for us to develop the AI. So in terms of this, some applications on the smart cities, for instance, I think this is, I believe there are a lot of development ongoing, not only outside from Malaysia, but here in Malaysia, I think there are a few players. Okay, even I think there are a few companies already provide the solutions, all right, ready for the market solution, no longer like the research-based solutions. All right, so this is the reality. So today we talk about 1 billion security cameras, 30 billion frame per day of image to be processed. A reality challenging real world condition. So normally when we talk about the lab-based scale solution, we make a lot of assumption, or even we don't care about the real conditions. For instance, traditional video analytic, not trustworthy. So this is the idea when we rely on the old image processing to do some of advancements of, for instance, people counting, as simple as that, traffic monitoring, for instance. I think in Cairo, we have several works that lead by our research members coming from crowd management, for instance. Yeah, people do on biodiversity, for instance. So, but this is the bottom line. So the reality when we talk about the industrial solution, the life cycle of the AI development so much concentrated on the MLOps developments. What I would say is more on the data analytics parts. And we need to have a good support system as we are solving the industrial problem. For instance, I think through our experience, what we try to develop is a lot of accessories or tools for AIs. For instance, in our lab, we are focusing on tools on auto labeling. So if you talk about detections algorithm, or we want to make a detection network, for instance. So we need to do some annotations, do the labelings, which is very expensive. Even one of few of our works for master student and PhD student, they just spend like 3 to 4 months to do their data labeling, for instance. So in our labs, instead of having a good algorithm for our AI developments, we also developing various tools. For instance, when we talk about data labeling, we have now our auto labeling tools to do data labelings. When we discuss with people, you can imagine when we talk to people from industry, which is new to the AI. So how we want to convince them? Once we convince, how we want to help them to make like a pipeline solutions from data curations up to the data modeling, and we make a full cycle, which is like an open loop. So we need to have various validation tools before we deploy our model into a system. So we need to do some validation with our client, for instance. So all these tools is very important. Auto labeling, validation tools, so that the expert can translate their understanding into what AI developer can do. All right. So simple as data curation, for instance. If you look on simple data set, so it's fine. Let's say we want to do people counting. People is, everyone knows that's a human. But if you talk about, let's say, a crack detection, for instance, only the expert can identify what exactly type of crack. If you talk about, let's say, 1,000 images for us to do the labeling. So from the labeling until the validations. So all the tools that we have developed in our lab nowadays can be easily accessed by our client, so that they can translate their expert knowledge into the AI developer to make the models better, for instance. Right. So this is just some sort of the idea. So let's move on the simple application on this one. Hopefully everyone can look on this. All right. So those who are new to this one, I believe I've been working with some of the local council. Earlier in 2018, we start with Penang local council. There are few. They are using drone to do car counting at that time. So this is a kind of application for that kind of problem. Yeah, it's quite straightforward with a certain altitude of drone flying, so we can easily detect a car, and then we want to find the space for the car parking, for instance, in the outdoor area. All right. So this is when we talk about medical imaging. So this is the reality. For instance, starting from 2007, people rely so much on the advancements of image processing. Okay, for instance, in 2012, the Krzyzewski of the University of Toronto won 2012 ImageNet computer image recognition by huge margin, okay, compared to the handcrafted software. So this is the breakthrough in 2010, 2012. So now there are plenty of imaging devices. The medical imaging devices company, they are come up with their solution with the AI solutions. Okay, for instance. Okay, for instance, if we talk about IDSIA competition detecting cell growth in breast cancer in Switzerland, detecting the rate of cell growth in breast cancer image is very difficult even for expert. Okay, so because what is the reality? The reality is the shape, the small spots, variations of shape, different colors. It can be easily confused. Right. So this is the real challenge that people are solving. I believe there are more and more ready solution in the market. So, but it's triggered from the various of research coming from a good medical imaging papers. Okay, like SPIE, SIBI, ISBI, MICCAI, for instance. Right. So this is some of the solutions on the early detection, triage and screening, diagnosis, quantitative analysis, okay, for treatment and planning and ongoing. So this is what vital to the radiology. So this is to your X-ray images, right? I have in our lab we have the opportunity last time to work with the radiologists to do to find specifically on tuberculosis, to find the specific regions using AI. All right. So this is a deep learning is entering the clinic. Okay, it is already available. Okay. So this is a deep learning in drug development, for instance. Okay, what best thing if those who are new want to see, at least you can start your research using this specific framework offered by NVIDIA. We have the Clara, which is a medical imaging supercom. So this is the library that available for you to open to use. All right, so this is the AI platform for self-driving vehicle. All right, so this is the reality. For instance, they start from data collection, train models, simulate, re-simulate on the simulations, and do the mapping. For instance, fleet of data collection car outfitted with a sensor capture the data that is required for the development of deep learning network for self-driving vehicles. This is the reality. For instance, one survey car driving for 4 hours per day with 5 cameras basically generates 1 terabyte of data per hour, or 1 petabyte per year at 8 hours per day, 2 petabyte per year. So all this data is very useful. It's very important to develop the AI model. Okay, then this data is used to train the deep learning algorithm with over 1 million images per DNN viewed as a best practice. Compact DNN use up to 3 million images. Okay, for instance, if those who are familiar with this area, we have the ImageNet. Okay, that's the where people talk about transfer learning nowadays. They are so much relies on the backbone like ResNet, VGG, for instance, with the ImageNet as the image to be trained on the backbone that consists of 1.4 million up to to 300 gigabytes of data, for instance. So all this data set, okay, in reality for the autonomous is being collected in reality, right? So, okay, here are some of the example. You can enjoy and look on different perspective to develop. From the perception, free pace perception, distant perception, weather, LiDAR perception, camera-based mapping, camera localization, right, on the LiDAR localization to the HD map, past perceptions, okay, and also the scene perception, for instance. Right. Let's have a look the other video that I have. Please enjoy this one. And then I believe in Malaysia we have good, even it's coming from UTM. I think I am happy to share. I think we have Dr. Hairi that working on the autonomous car. And for this event, I would like to extend my invitation. We have a good talk on Thursday to look on the autonomous landscape for Malaysia. That's going to be taught by Dr. Hairi, the Managing Director for eMovies, on Thursday at 2:30 p.m. On Wednesday, on 25th of May, this Thursday. So this is some of the applications. The resimulate. So this is the example. And then first, previously we have the medical imaging application, AI cities. We talk about the autonomous car. So those who are interested to run your application on the field, they have the EGX edge computing, for instance. Okay, so this is the idea. I think I would like to introduce something that you can translate or trying to make your software to be packaging into simply where you can deliver to your client, for instance. So do also new, for instance, we talk about Docker later on. So having a Docker as like a container to put everything needed for your AI to run, especially on the edge applications. So I would like to introduce the Kubernetes. Those who are new, I think Kubernetes is an open source container orchestration system for automating application deployment. All right, so let's say I think the data scientists and the data engineers already make a development run, the models run, and then how you can make a packages and it's seamlessly run into your client devices, for instance. So this is some sort of tools that you can utilize from the Docker, and Kubernetes is like the management system to manage your container, your Docker, for instance, right? So it was originally designed by Google and is now maintained by the Cloud Native Computing Foundations. Okay, So this is the idea. I think if you want to look on this one, so you can simply make it available to your client using this platform. So this is what we talk about, the edge processing, for instance. So this is the NVIDIA ecosystem for EGX, accelerated computing platform that enables companies to perform low latency AI at the edge. So basically, this is need to be ready for a lot of applications. Okay, as the 5G base stations ready for many applications like warehouse, retail, store, factories, and many more. Right. So this is you can utilize the NVIDIA cloud, basically, the GPU cloud. So this is a cloud native system used to describe a container-based environment. Cloud native technologies are used to develop applications built with services packages in container, deploy as microservices, and manage on elastic infrastructure, for instance. All right. So this is where you can have all these things and make it available into your edge devices solution, for instance. Right. So this is where there are some applications that people are looking on how Microsoft and EGX bring AI application to edge, for instance. Okay, so this is some of the architecture. So from the edge server, okay, and then NVIDIA EGX stacks, we have several technology that available. And then you just look on the ecosystem partner. So we also, as a developer, we can have our own solution for this one, for instance. All right, so this is some of the applications, okay, on for the edge EGX, okay. For instance, in BMW is using intelligent video analytics in South Carolina manufacturing facility to automate inspection. So this is for, I mean, the body stamping inspection. With EGX gathering data from multiple cameras and other sensors in inspection line, BMW is helping ensure only the highest quality automation leave the factory floor, for instance. All right, so this is some of the application that running. We call some of it like on the premise solution or the edge solution to do the inspection, for instance. So we talk on the intelligent video analytics. Again, there are branches into two. Okay, if you want to have a look, we have the any architecture. We can have the on-premise solutions or the cloud analytics. All right. So this is the and on top of that, when you develop, I think those who are new, if you want to make your development faster, you can utilize some of the library that available for you to use. This is called a DeepStream SDK. So you can make your IVA or your intelligent video analytics development faster. Okay, even you can do a lot of optimization using TensorRT, for instance. So what inside of this? So let's say if you are the academic world, so we just need to focus on either like a primary detector or the secondary classifier. The rest we can use the library that available where you can embed. For instance, if you utilize TensorRT, for instance. So even if your networks is already been confirmed to run, you can use some of the library like a TensorRT, or you can include your library into your DeepStream, and then you compile it and to make it like a full IV analysis, because it's not only to do the detection, but basically we need to do a lot of parts, including the tracking part. All right, so this is what available, but as since the beginning in our lab, I think we also developing our own IVA platform. So that's mean it can work for any video sources that running as AI video analytics. So earlier we running everything on the host computer, but this is basically giving us a lot of difficulties when we want to make it available to our client. So we have the input, we have the output here. So this is where we develop our library, including we can customize our AI algorithms here. And then in order to run seamlessly to our client, so this is what we have developed. We make it all the solution available under the Docker container, for instance. So again, this is what we need to have for the intelligent video analytics. That this is what we have developed. So this is now like the library. So when you have any video sources, then you can connect to the API that we have developed on top of the Docker. So then they can use for various applications, including for any type of application that covers from a dashboard, monitoring display, trigger another server, for instance, and physically connected to any cyber physical world through the actuator, for instance. So this is the tracking part, for instance. We need to make sure we can do tracking. So on top of this, what we want to highlight, so those who are new, I think want to explore more, for instance, like a GitHub. So this is what we call a Docker Hub. So what you can do, you can have all your solutions ready, then you can simply bring it into any other devices using this Docker. So you can even, I think for the academia, let's say if you want to introduce the AI class, sometimes we have to split from the AI algorithm to the AI environment, for instance, so that the student can focus so much on the understanding the algorithm. So what Docker can help you, you can have your environments ready, and then you push into the cloud, and then the students simply can pull down back to their devices, and then they can just focus on the AI algorithm rather than on the environment, because at least they can focus so much on the understandings on the AI development, mostly like a data analytics part. Okay, so this is some of the application on shopping. I think you have looked on this one. So in many industry, asset and facility to be uptime all throughout the years. So this is very important. So this Power AI been solved on this one. We also have some experience on working on this one. And then we talk about semiconductor defect, okay? And then we talk about industrial assets, for instance. Okay, you may ask how this is relevant to us in the oil and industry. Those who want to provide the solution for this one, there are a lot of things, okay? There are temperature sensor that are coming out of the turbo machinery that requires some maintenance, right? So this is the idea. And this is for the cybersecurity. And this is for ladies. All right, some of the applications. This is for insurance, okay? To provide a real-time claims using the translator, if you look here. And this is some of the applications, okay? Mix and match for ladies to purchase, for instance. So this is some of example I think share from our lab. That's our early work on this one. This is I think sometime in 2018 that we already started for this kind of application. Right, so this is our opportunity from Cairo last time. We have the opportunity to work with the livestock management in Australia last time. So this is the example, very simple problem, but again, it's quite challenging. I will share with you some of the real issues on this one. Okay, for instance, like this one. This is a drone flying at 10-meter altitude. So basically, we need to have the path of the drone, and then what we asked to do is basically we need to count the cows on the screen. If you look on this one, so this is earlier. I think it is quite straightforward, especially we talk about one season, for instance. Okay, so towards the end, what we want to generate for the client is the auto-generated reporting coming from the detections, autonomous drone fleets, harness the power of computer vision and deep learning, and finally make a useful report. But just to share some of the real issues here coming, including data capturing, climate changes, imbalanced data set. Okay, if you talk about data capturing, so this is took us sometimes to get the best drone altitude flying with the right image view to do all the monitoring. And then if you talk about climate changes, the video just now, I think in the next video, it is running during the, I think during spring, but all these things need to be addressed, not only during the spring, we need to solve during falls, during winter, and also during a summertime. So all season giving us a different environment or different lighting or different image representations. On top of that, we are talking about imbalanced data set. They also want to know about how many cows, and also want to know exactly what type of feral that coming to the area, to the paddock, for instance. So this is completely highly imbalanced data set. So this is when we're trying to solve. Earlier, we have a lot of options. When we start, we can do a lot of academia kind of research and development here. But towards the end, I think we found a lot of tricks when we want to develop AI. As simple as we make a feral, okay, like a wild boar, for instance, a kangaroo, for instance, to be easily created into the image with minimum number of cow to make it the data set balance again. So that what the AI can do towards the end, they can detect the cows and also they can detect the feral. All right, so this is some sort of the real issues we can cover, we can solve using many ideas. Okay, all right, so this is the old video. Okay, so I think this is during spring. So what we need to do, we need to find to count. The most challenging here is on the shadow of the cow itself. All right. So this is an example. And then once we manage to do this one, they have a company looking on the thermal processing of the cow, for instance. They're coming to our lab to do the conditions of the cow, for instance. Okay, trying to finish in 7 minutes time. All right. So so once we have all the modules, now specifically in our lab, we are doing on we are working with one of the company to do for smart assets management for telco industry. So this is our accessories that we have developed for drones, and then we are covering on the IoT communications with the LoRa sense coming together with the sensors. Okay, stream GPS and sensor reading using serial communications on the ground. And then we are also working on the video streaming design, where our previous experience on AI modeling on the specific conditions, especially on the outdoor conditions, that helps us a lot, where we spend a lot of time for the hardware development and to make it the system run. So again, we utilize all our earlier library that we have developed to any system that we're going to deploy in future, for instance. Right. So this is some sort of when I focusing some of my PhD student work. So they are just focusing on specific part of the algorithm blocks here. They don't need to know exactly what the system runs, but of course they're communicating with the engineers, the project, the programmers in our lab. But they are just focusing so much on a new algorithm. For instance, we talk about multi-hit solutions. Okay, so this is some sort of fundamental works to introduce on AI deep learning. So what we are focusing on different type of object shape, for instance, to do on the AI detections. So this is a very specific fundamental works on deep learning. We propose a multi-hit with attributes to detect an object, for instance. All right, he's just working a specific on this part, and then hopefully towards then we can compile it together to make it like a better solution for the existing version that we have, especially on the AI. So this is as we mentioned, we have a good facilities. So we have several machine. Even here I mentioned to share, we have the IBM GPU, the IBM infrastructure that running on V100 with a 4 GPU and 2 GPU. So this is what we are monitoring, for instance. So this is just I think asset management. All right. So we are running here. This one earlier we running on the cafe model, for instance. So this is some of the idea, one of the example that we are working on, how we make the previous understanding on having the full ecosystem, and then we translate it into very specific research work for our postgraduate student in our lab. And just now on the telco, we are working on multi-head. So for semiconductor, so I think you just share, this is our opportunity to work with one of the German foundries to do the specific defect inspection on the micro size of images. So this is our early prototype when we do, and even now we are trying to scale into cloud solutions. So this is the idea. So previously they have their a label to do the inspection. So on top of this, what we did, we do all not only the detection, we also do the object sizings. We do some of the measurements on the object size, because every single information is very useful for the foundries to know the root of the problem. All right, so we translated now into a SaaS solutions. So this is some sort of our solution now. If people want to use for the POC, they can simply log into our portal, then they can simply subscribe and then get the AI engine with the features on the security. So this is the ongoing project with us. With I think we have opportunity to work with now up to 3 semiconductor industry. So what the PhD student trying to do, they're just focusing on the AI engine. They look on specific part of the AI. So they are, this example, we are working on assemble and attention mechanism to highlight further on the defect that we have on the image, for instance. All right, so this is the idea. So we introduce some architecture for this one. So as a fundamental work, we need to do some benchmarking. Right. And then on top of this, just to share with you, when we're developing the SaaS solutions, you can simply skip all the difficulty that I have earlier. I think you can have a look on a Triton inference server. So this is make your life easier. You just need to focus on your AI engine, and then you can make your system ready running on the Triton framework, for instance. So you may have a look on the Triton, for instance. It's 10:58. Hopefully I can finish soon. So this is the idea. You can deploy your engine, okay, client applications, and then the rest you can get everything where the client can get the output through. For instance, if you want to have your dashboard, they also covered the Kibana, and this is the format that can be passed to the Kibana, for instance, using the Prometheus, for instance. All right. So that's another one, the opportunity to work with one of the utilities company. So what we did is in terms of the thermal inspection, so we provide the portal solution. And then what we did is a solution, and then the student focusing on a very specific network on the call attention gap network, so that they can have a better classifications of the thermal condition, for instance. All right, so this is the idea, using even the opportunity given by the power industry. Now we managed to develop our own thermal devices that can be easily connected to our AI portal, so that they, instead of save the images into their local PC, now they can simply push all the information directly from the device to the cloud. Right, so this is the idea I just share with you, and that's roughly the three focus, some sort of like development that we are focusing, coming from the telco. Then we have the opportunity to work with the semiconductor industry, and now we also have the opportunity to work with the power utilities. So that's roughly the idea. So we would like to open the collaborations to our lab. So this is our facilities, high performance computing platform. We have, as mentioned earlier, we have upgrading our lab. It costs us up to $500,000 for A100. We just secure one good grant, I think last 2 years. And then we also have the inference server that provide a service mainly for predictions on the AI. Okay, so I think this is the idea. We have our product that connect to our drone. I think that's all. I think this 11. Again, thank you, everyone. Thank you very much. Okay, thank you.